Welcome to PH1105 e-lecture. In this video segment, we will show the mathematically how you can add up two cosines, cosinusoidally varying sound waves to get a sound wave of a similar frequency but exhibiting the phenomenon of beats. So let's start with, let's say, a first sound wave that is given by x1 of t equals to a cosine omega 1 t, and x2 of t given by a cosine omega 2t plus phi. So we do not need them to actually have exactly the same phase, and in fact it is not possible to have two sound waves, in general not possible to have two sound waves that start off with exactly the same phase. So we can, for the discussion to be general, we can introduce a phase phi here, and the assumption here is that omega 1 is approximately equals to omega 2 but not exactly equal. So when these two sound waves meet in a particular region where these two time oscillatory displacement waves are measured. Okay, so since it's displacement, maybe I should put this as a y. Okay, so I should change this to y. So here, let me change this to y. Okay, so change this to y and change this to y, just to make sure that we keep our notations consistent. Okay, so this is y1 and this is y2, and these are displacements of two sound waves at a given point x. Okay, so this is at a given point x. Okay, when at this point, when you add up the two sound waves to get yt, you will have yt equals to y1t. Okay, so I'm writing too fast. This should be a plus. And I forgot to switch back to the pen. Okay, here we go. Plus y2 of t, and this we can write as a cosine omega 1 t plus a cosine omega 2t plus phi. Okay, now we need to recall a certain formula here, and that is, so recall that cosine A plus cosine B is equals to 2 cosine A plus B over 2 times cosine A minus B over 2. So this is the sum of cosine formulas, and it is, you can find it on Google, so you can Google it very easily, and we need to use this here to write down the resulting form of yt, and this will be 2 times A. So you see that these two cosines have amplitude 1, and after the addition, the amplitude becomes 2, so we need to put down a factor of 2 here. The original amplitude remains here, and then now we need the sums and differences between the two angles. So here, the first one, what we will have will be omega 1t plus omega 2t plus phi divided by 2, and second term will be cosine omega 1t minus omega 2t minus phi divided by 2. And I don't really need the bracket, but let me just put it down. And since omega 1 and omega 2 is approximately equal, let me write this as 2a cosine omega bar t plus phi over 2, where omega bar is equals to 1/2 omega 1 plus omega 2. So this is a frequency that is that is approximately the same as omega 1 or omega 2. In fact, it is the average between the two frequencies. And then we have cosine here, because it's omega 1 minus omega 2. Let me write that as delta omega over 2 times t, and then minus phi over 2. Okay, so this will have the same kind of frequency, this term here. So this first term here will be the high frequency term, and it will continue to look, the oscillation will continue to look like this. Now this second term is much slower, because omega 1 is approximately omega 2. Therefore, delta omega is a very small frequency. So this is a very slow, time varying envelope, and that is what. So if I draw it on top of the fast oscillation, it will look something like this. Okay, and then when you put those two together, when you multiply these two together, you will get something like this. Okay, so effectively, the fast oscillation modulated by a slow time varying envelope, and this phenomenon, if the frequency is slow enough, you can actually hear the sound intensity changing with time, and therefore this thing here is called the beats. Okay, so you can only get you can of course do this for any two different frequencies, but you hear beats only when delta omega is small enough. So if delta omega is large, then actually what you hear will be two different tones. One given by omega 1 plus omega 2 divided by 2, and the other one given by omega 1 minus omega 2 divided by 2.